Okay. We are about to start. Very soon we are starting. We are starting what we have been what we have been waiting for. What we have been waiting for. This is it. We are about to start in the next 2 minutes. We are going to start. I want every one of you to prepare your mind, prepare your soul, prepare everything you need to prepare. Because today, okay. Let's move. Let's start. Let's start. The first question. I want you to listen carefully. The first question. Which of the following is not a vector quantity? Which of the following is not a vector quantity? The quantity that's not a vector. What is a vector? A vector quantity is a quantity that has both magnitude and direction. A quantity that has both magnitude and direction is known as what? Vector quantities. What are the vector quantities? Please, you have to take note of them. We have displacement. Take note of this example. Jamb said this one. These are the examples that Jamb make use of under vector quantity. Vector quantity has both magnitude and direction. An example of vector quantity are displacement, velocity, acceleration. We have force, weight, torque. We have momentum, magnetic field, magnetic field strength, and so on and so forth. Please take note. Let me call them again. These are examples of vector quantity. We have velocity, displacement, acceleration, force, weight, torque, momentum, magnetic field, magnetic strength. We have impulse. These are examples of vector. They are examples of vector. Then we have what we call scalar quantity. Scalar quantity. This is a quantity that has no direction. It has no direction. It has only but as only magnitude. Only magnitude. Scalar quantity has no direction but only what? Magnitude. Only magnitude, no direction. What are the examples? All the fundamental quantities are examples of what? Of scalar quantity. All the fundamental quantities. That means we have mass, length. And when I say length, I mean altitude is also included. Altitude is also included. Height is also included. Distance is also included. They are all the same thing as what? Length. They are examples of what? Scalar. We have temperature. Temperature. But take note, temperature gradient is vector. Temperature gradient. That one is vector quantity. This one, temperature gradient is vector quantity. But temperature is scalar quantity. Temperature is scalar quantity. We have energy. Energy. We have work done. Work done. We have time. Time. We have time. We have time. Time. We have time. Take note. Time. We have resistance. Potential difference. Electric potential. Electric potential. We have all these. We have all these. We have current. We have current. All these are what? Are scalar. Jamb cannot go beyond this example. Take note. Then look at that structure. Which of the following is not a vector quantity? The answer to that question is what? Altitude. Altitude. Take note of that. Altitude. Please quickly write that in there. Write it down. Please. Today is today. Today is today. Today is today. Don't worry. Take note. Today is today. Let's go to the second question. Very important. Number 2. I will explain some things in number 2. I will explain some things in number 2. I will explain some things in number 2. Hope that you people can hear. If you can't hear us, please comment so that the technical crew can let me know. If you can't hear, please comment or thumb up. If you can't hear, please, so that we can quickly rectify it. Please. Second question. One of the following reading represents the measurement of the length of a metal rod using vernier caliper. One of the following, I will quickly explain something here. Vernier caliper. Hope you've written this because I will rub up this. Please be fast. I will rub up that. I will rub up that. Please be fast. Or let me rub this one off. Let me rub this one off. Let me rub. Let me rub. Okay. Class, when you have measurement of length, we have these 2-3 instruments. We have meter rule. Meter rule. We have vernier caliper. Vernier caliper. Vernier caliper. Caliper. We have micrometer, screw gauge. We have this. When it comes to measurement of length, this is used to measure what? Large length. If you want to measure what? Long length. A length that is what? Very large. We use meter rule. Vernier caliper is used to measure, when you remember this, VL is used to measure internal and external diameter. Take note. Vernier caliper V is used to measure internal and external diameter. Take note. Vernier caliper is used to measure internal and external diameter. VL. While micrometer screw gauge, we have this med. Micrometer screw gauge is used to measure only what? External what? Diameter. Micrometer screw gauge is used to measure what? Only external what? Diameter. Take note, the most accurate among them is what? Micrometer screw gauge is the most accurate because it is used to measure smallest distance. Please write it down before I give you the word accuracy. Before I give you the word accuracy. Before I give you the accuracy. Before I give you the accuracy. Okay, class, what is accuracy of meter rule? The accuracy of meter rule. Please take note. The accuracy of meter rule, that is least count. Reading accuracy can also be called least count. Reading accuracy can also be called least count. What is reading accuracy of meter rule? In millimeter, it is one whole number. It is a whole number. In millimeter, it is a what? Whole number, which is what? 1 millimeter. In centimeter, it is for 0.1 centimeter. That is 1 decimal place. It's in 1 decimal what? Place. 1 decimal place. In meter, it is 0.01 meter. 0.01 meter. That means 3 decimal place. That means the reading accuracy. That is the least count. The least count of meter rule. In millimeter, it is in whole number, 1 millimeter. In centimeter, it is what? 0.1 centimeter. That is 1 decimal place. In meter, it is what? 3 decimal place. 0.001 meter. 3 decimal place. That is what? The reading accuracy of what? Of meter rule. Take note. Let me give you the reading accuracy of vernier caliper. The reading accuracy of vernier caliper. The reading accuracy of vernier caliper. The reading accuracy. I'm sorry, the technical crew. I'm sorry. The reading accuracy of vernier caliper. Reading accuracy. Reading accuracy of vernier caliper. Reading accuracy of vernier caliper. In millimeter, it is what? 0.1 millimeter. That is 1 decimal place. In centimeter, it is 0.01 centimeter, 2 decimal place. Can you do 2 decimal place? 40.2. That is 2 figure after the word, 2 digit after the point. In meter, it is 0.0001 meter. That means 4 decimal place. Write it down. The reading accuracy, which is what? Least count. Least count. It is called reading accuracy or least count. Least count. Please write down. Let me give you micrometer screw gauge, micrometer screw gauge, micrometer screw gauge, micrometer screw gauge, micrometer. Let me write it here. I don't want to. My reading accuracy of micrometer screw gauge. In millimeter, it is 0.01 2 decimal place. In centimeter, 0.001, 3 decimal place. In meter, 0.00001, 5 decimal place. Take note. Then let's use that to answer this question. Let's use that to answer this question. Please write it down. Take note of this. This is what we use to answer that question. This is what we use to answer that question. Let us say, one of the following reading represent the measurement of what? The length of a metal rod using vernier caliper, taking the reading accuracy into consideration. That means the reading accuracy. In centimeter, what is the reading accuracy of vernier caliper? In centimeter, this is vernier caliper. The reading accuracy is for 2 decimal place, 2 decimal place, 0.01, 2 decimal place. That means the answer must be in what? 2 decimal place in centimeter. Which one is in 2 decimal place in centimeter? 2 decimal place in centimeter. Can you see? 2. After the point, we have 2 digits. 2 digits. After the point, 5.16 centimeter. Can you see? 5.16. 2 digits in centimeter. In centimeter, 2 centimeter. 2 digits, 2 decimal place. 2 digits after the point. 2 digits after the point. That means in 2 decimal place. Which one? Option D. That is the answer. Option D. Option D. Take note. Take note. Look at number 3, the same thing. Number 3, the same thing. Which of the following represent the correct precision? Correct precision. That means the reading accuracy. The correct precision, the reading accuracy of the length of a piece of wire measured with a meter rule. Which one? In millimeter. What is the reading accuracy of meter rule? In millimeter. In millimeter, it is in what? O number without any point, without any decimal place. O number without any decimal place. In millimeter. Which one is in millimeter? That is O number. Option what? A. Option A. 35 millimeter. 35 millimeter. Can you see it's a O number? Meter in a O number. In millimeter, it's a O number without decimal point. Meter rule, the reading accuracy in millimeter is a O number without decimal point. In centimeter, it is what? 1 decimal place. In meter, it's what? 3 decimal place. Look at the option. They are all in millimeter. Which one is O number? Meter rule. O number. Take note of that. Take note of that. Take note of that. I told you, meter rule measure what? Long distance. But if you want to measure short distance, we use our vernier caliper and micrometer screw gauge. Vernier caliper measure internal and external diameter. But if you want to measure external diameter, such as the thickness, take note, thickness, if they say thickness of a paper or diameter of a thin wire, diameter of a thin wire, we use what? Micrometer screw gauge. Thickness of a paper or diameter of a thin wire, we use micrometer screw gauge. But if you want to measure internal and external diameter, we use what? Vernier caliper. Take note of that. Take note of that. Let's move to the next question. The next question. Number 4. Number 4. Number 4. Woo, kaka. Number 4. Number 4. And before I move, I should have given you this also. The reading accuracy of stopwatch now is 0.1 second. Take note, the reading accuracy of stopwatch is what? 0.1 seconds. Stopwatch, if they ask you, the reading accuracy of stopwatch is 0.1 seconds. Let's go to number 2. The external and internal diameter of a tube are measured as 32 plus or minus 2 millimeter and 21 plus or minus 1 millimeter respectively. Find the percentage error. Find the percentage error in the thickness of the tube. Find the percentage error in the thickness of the tube. Find the percentage error in the thickness of the tube. What do we use to solve this? We have percentage error. Percentage error equal to error over actual what? Measurement. Percentage error equal to what? The error over actual measurement times 100 over 1. Take note. This is the formula. Let me write the formula. Percentage error equal to what? The error over the actual thickness or actual measurement of the substance or of the material times 100 over 1. Take note of that. Take note of that. Take note of that. Write that down. Write that down. Write that down. Write that down. Okay. From here, this is the real measurement. The external measurement, 32. Internal measurement, 21. Those are the real measurements. But these are possible errors. These are possible errors. Meaning that plus or minus 2 means what? The measurement can be 34 or 30. That means it ranges from 30 to what? 34. That means plus or minus 2. If I add 2 to what? 32, I will be at 34. If I take 2 away from 32, I will have 30. That means these are the possible what? Errors. For this one,